Hi, my name is Daniel Grabowski.
And my name's Chris.
This is the eight queens problem. This is group project 2. And the assignment requires us to develop a program that is able to come up with instances of a chess game board where eight queens have been placed and none of them can attack each other. And a queen in chess is allowed to make any horizontal movement, any vertical movement, and any diagonal movement. So a possible solution would involve eight queens on the board without any of them interfering with those possible movements. We kind of looked at this problem a few different ways, but what we decided the main things we would need is, first of all, a way to display the game board, display the chessboard, and we decided to go with something that prints out the rows and columns with periods and cues representing empty spaces and queens. The next thing we knew we needed was a method to check whether or not each of the if the position of the queen was placed in a valid space, meaning if it's in the line of an attack or if it's not in the line of an attack. And then finally, we would need our actual recursive method that is going to continuously call itself and check if a space or the next row, it's going to check the spaces in the next row to see if there's a possible solution for each placement of the queen. And if it's not, it's going to go back and start off at the last place that the solution was valid.
All right, and so moving on to the actual code itself, we're starting off by initializing the size as a final to be 8 because we're not changing that size. Next, we're adding that to an integer array, and then going down to the main method right here. We're starting off by solving for row 0, which we're doing by calling the queen method. Moving down, this method is a recursive backtracking method to attempt to find positions where the queen until the correct space is found. First, we're starting off with the base case. And if row equals the size, then we'll display the actual board itself, which we'll get to later. Moving down to the recursive case, we're using a for loop to loop through the board and find the column and the row. Here we're looping through the columns and until it gets to the size of 8. And then finally down here we're seeing if it is a safe spot to add in the next method, then we're going to add the queen by using this right here. Next we are recursively solving for the next row by adding 1 to the parameter. Going down here to the isSafe method, we're using a for loop to check each space. So here in the if statement, we're checking if it is in the same column, if it's in the same row, or if it's in the same or if it's in, I'm sorry, not the same row, the same diagonal. This is messed up right here, or the other diagonal. And if that is true, then or if that is the case, then we're returning false. And if not, then we're returning true, which goes up here. Finally, down to the display, if it reaches its size, we're iterating through for each row and each column until we're using this to find if it is a space for the Q or for the queen, and then we're printing out that space Q. If it's not, then it prints that open space as a dot, and then it goes down to the next lines. So yeah, that's basically our program. And then going to the actual testing part, as you can see right here, we have many different possibilities of it matching up. It is 8 by 8, as you can see, 1, 2, 3, 4, 5, 6, 7, and 8. And going down is the same way. But as you can see with this first one, it is testing Q for the first one. That's the first one that pops up because it's in the first row, first column, first space. So going down, it matches, going diagonally, it matches. And that is the case with the other ones as well. Thank you very much.
Thanks.